Now, if we look for the shapes of the compounds like XeF2, XeF4, F6, XeOF2, FOF4 and XeO3, we will see these kind of shapes. As we have already discussed in chemical bonding on the basis of VSPR theory, that we can actually predict the shape depending upon that how many bond pairs or lone pairs it carries. So, by looking at that, we have like XeF2 as linear, that is distorted trigonal bipyramidal becomes linear, and here distorted octahedral becomes square planar, distorted octahedral, this is distorted tetrahedral becoming trigonal pyramidal, and this is distorted again octahedral becoming square pyramidal, and here distorted trigonal bipyramidal becoming T-shaped. So, as you all know that how to draw these shapes, but still I will do one example for you. So, let us take an example of XeF2, that how you predict the shape. We know that like if we need to predict the shape, so there is a formula for that, for predicting the shapes on the basis of VSPR theory, that you get bond pair and lone pairs. So like that I am just going to calculate total electron pairs. So half into my central atom, valence electron of my central atom 8 plus number of atoms it surrounds 2, so it becomes 5, that means it becomes AB5 somehow, but let us now take the number of bond pairs and lone pairs here. So bond pairs out of this total electron pairs, so this is total electron pairs, out of that bond pairs will be this thing, number of atoms which are joined, that is 2, and lone pair will be 5 minus 2, that is 3. So it becomes which case of AB5? It becomes AB2L3, and we know that whenever we have 3 lone pairs in this thing AB5, we arrange them in such a way so as to minimize the repulsion. That means the geometry is going to be distorted trigonal pyramidal, and we are going to place the lone pair here, so it becomes a special name for that, this is linear. So this is how you are going to predict all of them, like XeF4, one more example. Suppose I have XeF4, so again Xe is 8 and F is 4, so it becomes half into 12, comes out to be 6. Out of 6, so total electron pairs 6, out of that bond pair is equal to the number of atoms, that is 4, and lone pair is equal to total electron pair minus bond pair, that is 2. So that means it is AB4L2. So that means it is a case of octahedral, so it has 2 lone pairs, so you are going to arrange the lone pair in this manner to minimize the repulsion. So this is how you are going to predict the shapes, but if you in case have any difficulty, refer to my lecture of chemical bonding of VSPR theory. You will be able to know that how these structures can be drawn, but still for your convenience I just demonstrated with an example. So you can just try out on these things and you will get the proper view of these structures.